Okay, thank you for everyone who joined our lecture. Before we will start the lecture, I will announce some organization points. First of all, the lecture will take about 1 hour. During the lecture, you can ask questions. You can text it on chat. I will read them, and the speaker is asking. Please text the questions in English, and I think we can start.
Perfect. Let me share my screen.
Okay.
Perfect. Igor, can you see my screen?
Yeah. Oh, everything is good. I see.
Perfect. Okay. So first of all, hello everyone. Thanks for joining in. I think it's afternoon where you are based. So good afternoon all. It's still a morning in London, but yeah, wishing you all a good afternoon, and I hope you've had a nice weekend. The topic is, I think by now you would know how AI is revolutionizing supply chain and logistics. And I think the topic is partially true, but in the presentation itself, I would also speak about not only how it is already revolutionizing supply chain and logistics, but also what sort of trends are we seeing and what potential future developments are there in the sector, and what fancy stuff or gadgets you can expect to see very soon in supply chain and logistics. So hopefully this presentation would have a bit of everything for people either who are super interested in the topic and also those who do not have maybe a background but are looking to learn more. I think it would be useful information for both. So jumping right in. So in terms of contents, I think the contents are laid out here. I will begin with an introduction about myself. I think would be a good icebreaker. What my background is, how did I come across AI, and what sort of background I have to speak on the topic. So I think that would be good. Then I'm assuming, or I mean, even though if no one has a background in e-commerce and supply chains, I have a slide where I go very basic into explaining how the supply chain in e-commerce sector looks like, so that even people who say do not have a lot of experience would be able to catch up and then follow the presentation. So that would be in the section 3, typical supply chain in e-commerce. Then we will shift gears and I'll speak about AI in 5 areas where it is already influencing positively supply chains, and that would be demand forecasting, last mile delivery, fraud detection, service logistics, and sustainability. So that would be around the impact AI already has had. And then, like I promised, I would speak about autonomous systems. So first with the definition of what they are, and then really speak about 4 technologies which I see will impact or influence supply chain and logistics in the coming years. So that would be autonomous vehicles, autonomous drones, autonomous robots, and autonomous assistants. And then, like any technology, having discussed the advantages and the pros, I will shift towards the challenges that I see would exist in the sector once we realize all of the good stuff I mentioned before, and then closing it out with future trends and where do I see further development in the space. So that would be roughly the contents of the presentation. So without further ado, let me jump to the next slide. Like I said, quick introduction about myself. My name is Maimoon. So starting from the last degree I have had, I did my MBA from University of Cambridge, UK. Before that, I am a mechanical engineer, so very technical background I have before that. So I did my master's in mechanical engineering from Germany, and then my undergrad is in mechanical engineering as well from Pakistan, where I'm originally from. So that is where I come from, and then work experiences. So I've worked in various automotive companies, Bosch, Volkswagen, Denso. So that is the automotive background that I have. And right now I'm working as a senior program manager at Amazon in London, UK. So yes, so that is my latest role. And then 2 fun facts about me. to lighten up the atmosphere as well. So I've lived and worked in 8 countries, so have had really the chance to travel and explore cultures. So that is something which is very dear to me, which I love. I love traveling. And then the second one is have taken a ride in 4 of the 10 fastest roller coasters in the world. So again, like my adventures as well. So this is a bit about myself. Jumping into the next topic. So like I promised, I wanted to have this slide. I understand there would be some of you who would already have a good foundation in AI, in different technologies within AI, but I wanted to have this uh, part in the presentation so that at least we start and set expectations on the basic level so that later on when I refer to a technology being used, so we are on the same page. So hence this slide is there. I think if you get bored, feel free to have a quick look on your mobile and then come back once you're done. So drilling deep down, I think we know AI is creating a lot of buzz these days. Everyone is hyped about this technology that it would do everything. It would be super for humanity. There are others who say it would take away all jobs. So it's a very mixed opinion or views that you hear about AI. So what is it at the core of it? AI refers to machines or systems that mimic human intelligence to perform tasks like problem solving, decision making, and pattern recognition. So examples include chatbots like ChatGPT, which is, I think, super famous everywhere now, self-driving cars, AI-powered recommendation systems, for example, Netflix and Amazon. Machine learning is basically allows computers to learn from data without explicit programming, using algorithms to identify patterns and make predictions based on that data. While deep learning is a subset of machine learning, where it uses artificial neural networks to mimic the human's brain's structure, enabling complex pattern recognition from large data sets, often performing better on tasks like image and speech recognition than traditional machine learning methods. So essentially, it is deep learning is a more advanced form of machine learning with more intricate processing capabilities. Coming to computer vision, it is a type of AI that allows computers to recognize and understand visual information. It uses digital images and videos to analyze and interpret the world around it. Coming to natural language processing, or NLP as it is called, it allows computers to understand, analyze, and generate human language. NLP uses machine learning to analyze text and speech, and it can be applied to any language, and it can process real-world input such as text or voice and make sense of it. Coming to reinforcement learning, or sometimes referred to as RL, is again a machine learning technique that teaches software to make decisions by trial and error. It is based on the idea that actions that lead to desired outcomes should be rewarded, while actions that do not should be punished. Sensor fusion is a process of combining data from multiple sensors to create a more accurate understanding of the environment. It can be used in many applications, including robotics, navigation, and driver assistance. And finally, on the slide, edge computing is a distributed computing framework that processes data close to where it's generated. This allows devices to respond to data faster and more effectively. So this is a quick whistle-stop tour of what are the different AI technologies. And I think my ask of anyone who's joining the call would be the next time when you see an AI application, really in your mind, try to think, okay, which of these buckets is the technology falling in? Plus, it can be also the fact that it might be combining more than one technology in a certain application. So just keep an eye open from the next time you see an AI application. Now, jumping to the typical supply chain e-commerce, linking back to the original topic of how AI is revolutionizing supply chain and logistics. So I thought it would be good to give you a basic background into how does the supply chain in e-commerce look like, what are the different jargons or technical terms that exist within, so that when later on I refer back or I mention a technology, you remember what am I referring to. So within the supply chain, there are basically three legs or three journeys or three parts to a vendor producing something, manufacturing a good, and then finally it reaching to your doorstep through your Amazon delivery or your any e-commerce platform, Alibaba delivery to you. So the first leg is called the first mile. So this includes the manufacturer basically manufacturing something, sending it out to the distribution center, and then any modes of transport driving it to the origin warehouse. So that is all covered under first leg or first mile. The middle mile includes again transportation, could be air through a plane, through the ocean, or through road, and then it reaching a intermediate destination or a warehouse, and then this is called middle mile, and then finally a van taking it to the final warehouse from where through the last mile it is delivered to either a store or to a customer. So this is the typical journey a parcel goes through in its journey from being manufactured all the way to being delivered to your doorstep. Now, coming to some Amazon acronyms, so that I mean, I don't know if it is something which you would want to do in the future. So, if you ever were to, for example, interview for Amazon, you would, I mean, this background would really help you of how Amazon names it. And I think this is not only true for Amazon, but lots of other e-commerce players as well. That the first mile is normally referred to as fulfillment center, so the warehouse where everything is stored. And just to give you an idea, fulfillment centers are mostly outside major cities. As you can imagine, real estate in cities is much more expensive than having real estate in far-flung areas. So fulfillment centers are generally based outside of major cities. And then they start their journey there. Then they are transported to sort centers where parcels are sorted. And then finally, delivery stations are basically mostly based in cities or just outside so that vans can drive in, pick up the goods and deliver to customers. So this is a typical journey of a package starting upstream all the way to reaching you in person. Coming towards so having laid the foundations for what exactly e-commerce is, what first mile, middle mile, last mile mean. Coming to some applications of AI within e-commerce and the supply chain. So the first one is predictive analytics for demand forecasting. So something an application of AI which has seen tremendous rise is around using AI to forecast demand. So what happens is AI analyzes historical sales, so basically sales from previous years, sees seasonality effects, also sees economic trends. How is the economy doing? Is it increasing? Is it improving for the better, or is it getting worse? And then also market conditions to predict demand accurately. And why would we need that? It basically means that you can reduce stockouts. Stockout is when a customer places an order, but you do not have it in inventory to fulfill it. That is a stockout. And then the converse or the opposite could also be true, that you are storing lots of items which never get ordered. So you are occupying real estate in your warehouse, which is equivalent to a dollar figure. So both of these situations are need to be optimized in an optimized supply chain. So this is where AI can really help in learn from past experiences, take in current trends, and then predict which items do you need to store, which items you can safely remove from your inventory. I think the best example of this is Amazon because it uses a very sophisticated AI-powered forecasting to manage vast inventory. And I think just to give you an idea, one of the metrics that Amazon uses is called last in stock, which measures the amount of time that has passed since a product was available for purchase. And why is it measured? It helps sellers and inventory managers to track how long an item has been out of stock and assess its impact on sales, ranking, and customer demand. So again, why does last in stock metric matters? Because again, stock out analysis identifies products that frequently go out of stock so that the AI algorithm learns that this is a high running item which I need to store. So that feeds into the logic. And then it also helps to estimate lost sales so that to see what revenue we could not realize because of this. And then it feeds into the parent algorithm on taking it as a negative factor and learning on the go. And then obviously customer experience impact is huge. As you can imagine, anytime you go into your favorite e-commerce platform and you want to order something and you see the order is not available or the item is out of stock, you do have a negative experience which can end up with either you going using a different platform. So there are significant repercussions of not fulfilling or not having enough of a selling item in your inventory. So therefore, AI can help in all of them basically. Jumping to the next topic, again, AI in last mile delivery. So if you remember from the previous the opening slides, where I said last mile delivery is the part where the item has reached your a warehouse near the city, and now what will happen is the final mile, including the van driving in, collecting the good, and delivering it to your doorstep needs to happen. So here again, AI has seen tremendous applications, both in terms of route optimization to find the fastest, most fuel efficient delivery routes. And what happens is there are lots of IoT sensors which are installed within these uh, vans, or I mean, in some cases in London, for example, you do have mopeds and bicycles, electric bicycles as well, but keeping it to vans only for the sake of discussion. So that is another application which has seen tremendous uptake recently. And one example which I would like to mention here, and shifting away from Amazon this time to UPS, is UPS uses AI-driven Oleon, which stands for, like the slide says, on-road integrated optimization and navigation to save millions in fuel costs. So what is UPS's Oleon? It is basically a powerful AI-driven route optimization system that helps drivers take the most efficient paths, reducing fuel costs, delivery time, and environmental impact. So how does it work? It analyzes data from GPS, package deliveries, and real-time traffic to suggest optimal routes. It is so detailed in nature that it even reduces left turns, because on average a left turn consumes more fuel and more time. So it even optimizes for having the driver take less turns and preferring right turns over left turns to basically ensure that idling time and fuel consumption are optimized and reduced, thereby leading to less emissions. And then it uses machine learning to continuously improve routing based on new data. And this is a classical case study where UPS recently claimed that they saved around 10 million gallons of fuel annually and significantly reducing CO2 emissions. So it ties very well into the green drive and green initiative that normally companies are taking for last mile delivery as well. So overall, what does this mean? So it provides real-time adaptability. You can adjust routes dynamically based on traffic. It delivers significant cost savings, and then the sustainability impact is also significant. Now, one thing I would say here is the example I gave was UPS, but I think Amazon is working really hard on last mile delivery optimization as well. Amazon's routing system is also a complete science in itself, with very sophisticated algorithms working in the background. So if the delivery time is 9 hours, the system learns how much time is it taking a delivery driver to basically complete its route. So for example, if the delivery window is 9 hours, which is typically more or less true in Europe, if the driver takes anyway less, for example, if the driver completes the route in 7.5 or 8 hours, the algorithm learns that, okay, this route I laid out to a driver and they were able to finish it in 7.5 hours. So the next time, what the algorithm would do is to give more shipments to that route to fill in the 1.5 hours extra that were saved. So basically, a good driver who is really good in delivering would make the job more difficult for someone who is not as good, because the next time the chances are that the system would learn and give out more shipments to drivers uh, for that route. So it does have this reinforcement learning part to it as well. Moving on to the next slide. Uh, so this again, another application of AI in supply chain and logistics, which is gaining traction, is fraud detection. So AI can detect anomalies in financial transactions, orders and shipments, preventing fraud in supply chains. So basically, using AI to see trends again, and then identifying patterns is another thing which AI is enabling. And another very important thing that I would like to mention here is that predictive AI helps also not only detect fraud but also identify risks in supply chains. So, for example, geopolitical issues, natural disasters can all be identified, or at least a first input or first information can be obtained from them. Example being IBM Watson uses AI-powered risk analysis tools to detect disruptions before they happen. So how does it do it? So predictive analytics uses AI and machine learning to again study historical trends. And then natural language processing is another form of AI that it uses to scan news, social media reports to detect early warning signs of disruptions, and then provides actionable insights to prevent issues before they happen. And now, from my experience, one example which comes to my mind is when I was working for an automotive company, a Toyota group company called Denso. So, if some of you follow technical news a lot or are interested in semiconductors, they must remember in 2021 there was a semiconductor company called Renesas Electronics, which had a plant in Japan which caught fire, and there was a significant supply chain disruption globally for companies who were procuring semiconductor chips from that maker. So again, it led to a disruption of around 2 or 3 months where OEMs couldn't get deliveries, and the whole automotive industry had a severe effect, ripple effect on itself. So again, using natural language processing and also AI, it can be possible to have suppliers in the loop already, so that in case of such disasters or emergencies, there is already a mitigation plan in place to select the nearest vendor or supplier to basically fulfill orders. So this is another application which I wanted to mention. Now coming to chatbots and service logistics. So yet another application of AI, and I think this is something which everyone would have seen in one form or the other, where you go to a website, you have, for example, you want to return an item and you are directed to a chatbot, or you have some other utility service and you're contacting them and they have set up chatbots. So I think in one form or the other, everyone would have interacted with chatbots already. So at the core of it, they use natural language processing and enhance customer experience by providing real-time updates and solutions. So example being DHL's AI-powered chatbot, which is very sophisticated. So what it allows is it allows real-time shipment tracking. Customers can check package status using chat platforms like WhatsApp, Facebook, Messenger, and DHL's website as well. Uh, the fact that it has neural language processing built in means that you can query in multiple languages and respond and get immediate responses. I think one of the biggest advantages is also that it's available 24/7, and it eliminates the need for companies to have call centers and have have customers interact with call centers. So that is another customer experience part that is realized through this. And then also it can give you proactive notifications, give you alerts on when there is a delay in delivery, and also tell you estimated delivery times. And then I think the benefits, like I said, customer experience is improved significantly. It reduces workload for human workers, and especially workers who do night shifts. It can be really good. It can be really good to help them through AI in that application. And then finally, obviously, it improves efficiency. If any query that you have goes through you or goes through AI, and then only if the AI deems that there needs to be a human input, they can always rope in or loop in the human. But for any other queries, they can answer the query, and leads to significantly reduced processing times in terms of queries. So that is another application where AI has seen tremendous uptake, and regard not only in supply chain and logistics, but also in other sectors as well. So coming to again AI in sustainability. So I think this is an area which people might not really appreciate or might not be fully aware of. But AI is significantly reducing carbon footprint as well by uh, optimizing supply chains for sustainability. And how does it do that? So AI models predict eco-friendly transport routes and minimize energy consumption in warehouses. And here my example would be MERS, uses AI to optimize ocean freight routes, cutting fuel costs and emissions. So Maersk is one of the world's largest shipping companies, and it uses AI-driven analytics, weather forecasting, and real-time data to enhance operational efficiency. And how does Maersk do it? It uses, firstly, AI-powered weather forecasting to adjust routes based on storms, ocean currents, and wind patterns to avoid delays and rough seas. It ensures fuel efficiency through optimization, where the AI suggests the most efficient speeds and paths, reducing unnecessary fuel burn. Also, it allows for dynamic scheduling, uses machine learning to adjust port arrivals for minimal waiting times and congestion, and also predictive maintenance. AI monitors vessel performance and detects potential mechanical issues before failure occurs. So, what is the business advantage of all of this? You end up with significantly lower fuel costs, you reduce emissions, you increase operational efficiency because imagine ships arriving on time with fewer delays and optimizing docking schedules. So all of this uh, drives a flywheel, which is net positive for carbon emissions. So that is another advantage there. One example I would give from my own experience as well is Amazon has also a huge initiative on sustainability, and Amazon's 2030 target for 2030 is to have 50% of all its shipments to be package free. So if any one of you has ever ordered or used Amazon, you would know that any Amazon shipment comes in a very specific brown colored Amazon packaging. Obviously, it's great for you as an experience because your shipment doesn't get damaged. But then again, it is environmentally unfriendly, as in the box that you generate, because most likely you just when you get the delivery, you take out your shipment and throw it away, and it is significantly bad for the environment. So in one of the projects I was doing with Amazon, what we did was we looked at how can we reduce packaging. And what we came up with was any Amazon shipment goes through various cameras through its journey into its supply chain. So what we did was we set up machine vision to basically identify shipments which we could potentially ship without packaging. And how were we doing that? So basically, for every shipment that passed through a camera, we were collecting attributes or features. For example, does the item have perforations? Does it have protrusions? So items with complex geometrical features we were not including because downstream it has quality impacts because there are only certain types of items that you can send without packaging, and they're still surviving the rigorous stresses and pressure that Amazon's value chain puts on a parcel. So through that project, we were able to deliver significant savings. And on an environmental angle, because as you can imagine, like I said, if a shipment reaches you without its packaging, it is definitely better for the environment. You save out on all the packaging and all the recycling costs it would have taken. Secondly, it also helps Amazon in terms of a labor spend point of view, because imagine if you are able to send a shipment without its packaging, it saves one process to Amazon, which is basically a worker taking a package, putting an overbox around it, then sealing it, and then sending it out. So also from a labor cost standpoint, it is better for Amazon. Then also think about transportation costs. So even though it might not look a lot, but when we did a deep dive, we did see that it significantly reduces transportation costs as well, because an overbox means you have more volume within of the shipment, which occupies more volume in your trucks and then later in your vans when out on delivery. So there is this transportation costs angle to it as well. So basically, through the project, we were able to optimize for 3 or 4 features or 3 or 4 costs, which was really good. So again, an application of using AI to drive sustainability. Now, this is a new section in the presentation. I think, like I said, till here we have covered more or less applications which are already in the air or applications which you already are seeing around you. But now coming to applications which are more in the pipeline, as in they have not been fully realized yet. So you might say that this portion is more based on at least some parts of it is more based on how the deliveries ecosystem would look like in 5 years. But I thought it would be super interesting to have a sneak peek into what the sector is doing, how is it looking, and what innovations can we expect in the next 3, 4, 5 years. So again, starting off with the definition so that everyone is on the same page with what are autonomous systems. So AI-driven autonomous systems are systems capable of making decisions and executing actions with minimal human intervention. So examples being self-driving cars, industrial robots, smart assistants, and drones. So why does it matter is because they enhance human efficiency, reduce human enabling large scale automation. So those are the advantages. And then from a business standpoint, the global autonomous systems market is expected to reach at least $150 billion by 2030. So I mean there is significant financial reasons for being interested in this topic as well. Now, coming to areas within autonomous systems that would impact supply chain and logistics, and they include autonomous vehicles, autonomous drones, industrial automation, where it includes AI-powered robotic arms in e-commerce and manufacturing, and then finally, smart assistants and robotics. So basically, AI-driven home robots or yeah, AI-driven home robots or assistants. So those are the four areas where I see lots of action happening in the not so distant future, and hence the need to study it thoroughly. Now, starting off with autonomous vehicles. So I think something autonomous vehicles is something which are very dear to me because based on my extensive experience in automotive and having worked with the autonomous driving cars and robots a lot, I think it is something which I consider myself decently knowledgeable in this area. I think there are several key players in this area who are doing great work, and they need mention. I think most of you would have heard of Tesla's and Waymo's work on this area, but there are other players like Cruise, NVIDIA, Pony.ai, Zook, and Bedu who are doing significant work in R&D. And of course, this is not an exhaustive list. Lots of good work is being done in this area. And then I think this would be a big facilitator as I build into my presentation. You would see that how development in this area would also revolutionize supply chain and logistics in the future as well. Now, coming to quick introduction or understanding of autonomous vehicles, how do they work? So basically, they're basically cars that rely on sensors, actuators, and complex algorithms, machine learning systems, and powerful processors to basically execute software. Essentially, what they do is they create a map of their surroundings, especially the LiDAR-enabled ones, to navigate. Video cameras are also primary sensing mechanism in other types of AVs as well. What is LiDAR is basically light detection and ranging. It basically uses pulses of light to to basically hit objects and develop a map, and then detect obstacles and then path plan accordingly to the map it has made. So that is essentially how LiDAR-enabled cards work. Whereas in case of vision detection, it's more around computer vision and identifying objects the natural way we do with our eyes. So that is the distinction between the two. And then there are other types of sensors as well. For example, ultrasonic sensors in wheels to detect curbs and other vehicles when parking. So as you can see, it is a classical example of sensor fusion where you have multiple sensing means and you are combining information and data being collected in all these different mediums into one source and then forming or taking decisions on driving. So like I said, classical definition of sensor fusion which is the underlying technology in autonomous vehicles. Now, the obvious question would be, okay, great, we can have autonomous vehicles, but what are the benefits of having autonomous vehicles? I think there are lots of benefits. One would be the social angle. Uh, Elderly and handicapped people would have independence, would have mobility. I think that would be great. The other one is reduced carbon dioxide emissions through uh, autonomous vehicles. And how would that be realized? It's basically there would be a coming together of three technologies to basically realize these gains, which is EV, AV, and autonomous, which would drive this improvement. And then what this would mean is you would have reduced congestion, you would cut transportation costs, you would have improved walkability and livability, you would free up parking lots, and then you would reduce carbon emissions by 80%. So these three technologies together, again, electric vehicles, autonomous vehicles, and ride sharing, will unlock significant benefits in the future if they see mass adoption. And then just building on from my last slide on the advantages of autonomous vehicles, a study done by University of California and ITDP estimated the power AVs, EVs, and ride sharing will unlock till 2050. The three scenarios mention this in detail, that if we were not to have this coming together of technologies would lead to 4,600 megatons of emissions and 2.1 billion vehicles on the road, which sounds like a huge number, and is definitely a huge number as well. Whereas if we are able to come up with these three technologies, combine them together, the overall vehicles on the road till 2050 would only be 0.5 billion and only 700 megatons of carbon emissions. So hence is a significant uh, reason for also ensuring that these three technologies see the light of the day and then see mass adoption, because long term it would be beneficial for the environment as well. Now, coming to the question of where do we stand? So great, I've told you a lot about autonomous vehicles and how I see they could be adopted, but where do we stand now in terms of realization of these technologies? So like I mentioned earlier, two basic approaches can be there, either through LiDAR or through vision. So Tesla uses cameras as in vision to navigate and path plan, and is at currently at level 2 automation. So if you see the graphic, it basically details what the different levels of automation mean. 0 means no automation, 5 means fully automated, and Tesla is at level 2, and level 2 simply means that the driver must remain attentive and ready to take control at any moment. Tesla does have an autopilot and includes features like traffic aware cruise control and auto steer, whereas Waymo uses LiDAR to map its environment. Once mapped, the car can navigate autonomously, with the caveat being the area has to be mapped before. What this means is, for example, Waymo already is working fully in some parts of the US, especially in the West, so San Francisco and the West Coast. But it can only path plan and navigate in areas for which it has been mapped. So although it has reached level 4, but it has reached level 4 only in surroundings which it has already seen in the past. So that is a footnote I would like to make. And like I said, level 4 means the vehicle can operate fully autonomously within specific areas and conditions. So minimal human intervention is needed in terms of level 4. So there are various other companies like NVIDIA, Pony.ai, who are not developing vehicles of their own, but are providing platforms to basically other AV makers to basically use to realize autonomous driving. So that is the piece on autonomous driving. And then coming to the next technology, which is advancement in autonomous systems around drones, another area which is seeing tremendous adoption as well. Uh, I think you must have, I mean, if someone is from the countryside, they would have seen at least initial levels of adoption in of autonomous drones in farming. Uh, that is one application, but since the topic is more on supply chain and logistics, one area which is very interesting is delivery through drones, as in your package delivery. So Amazon, through its Prime Air initiative, is working a lot in this area. And the goal of Amazon is by 2030 to have deliveries enabled in less than 30 minutes. So that would obviously mean through delivery through drones. So very exciting times ahead. And then one other thing I would mention here is I did get the chance to do a consulting project with another drone company some years ago, and without disclosing much information, I mean, it is going to be very interesting times in this area in terms of drone delivery and how it would develop, and then how it would become the normal form of delivery. So interesting times lie ahead in this area as well. Now, coming towards robotic arms, I think we all have seen robotic arms being part of manufacturing sectors for a significant time. But manufacturers are now, and especially e-commerce companies, are now investing in developing factories that are fully automated. Tesla's Gigafactory is one example, with only a limited number of humans present who are only supervising robots and doing tasks too complex for robots. I think within the supply chain and e-commerce sector, I think the biggest player has to be Amazon, and then its acquisition of Kiva Robotics in 2012. And at the time, for I think it was around $1 billion. And at the time seemed not a logical choice, but then again over time it has shown that it helped Amazon gain significant advantage in efficiency in its fulfillment operations. Uh, so Kiva's robots improved efficiency, speed, and cost savings in Amazon's fulfillment centers. So what Amazon is able to do now is have orders fulfilled faster. The robots have increased efficiency and productivity. There is a significant cost reduction piece to it as well, because as you can imagine, once you can reduce labor costs and order processing times, you can pass on this benefit to the customer who has to pay less. And I think the flywheel Amazon talks about is realized through this, that the lower costs drive yet more orders. So that is another area which Amazon has able to realize. And then the significant competitive advantage that Amazon has been able to gain through the Kiva Robotics acquisition all those years ago has meant that again Amazon has positioned itself as the market leader in this area. And then just to give you an order of magnitude, Amazon has around 750,000 robots in all of their warehouses globally, which shows the amount of automation that exists in the company. Now, coming to advancements in, again, smart assistants and robots, AI-driven robots, I think we have not seen this application fully yet, but I do foresee that in the coming 3 to 5 years, we would see significantly more AI-powered robots also in warehouses, where they would be working on tasks which are not non-value adding, and relieve humans of those non-value adding tasks. And also, on the other hand, I would like to mention smart assistants within homes. I think the future of the orders would be through smart devices such as Alexa, where you would be able to. I think it already, the functionality is there, but has not seen mass adoption yet. But I see that would not be the case in the future. You would see orders being placed through Alexa, customer returns being processed through Alexa. So those are the type of trends that I see happening also in smart assistants area. Now, having painted this long picture, I think one thing is clear, that within autonomous systems, uh, AI is shifting more from an advisor to a decision maker. And what I mean is, the classical use of machine learning would have been to train the algorithm on a certain piece of data and then get a prediction out of it. But whereas in all the examples I have given around autonomous vehicles, autonomous drones, and smart robots and smart assistants, you would see that AI is transitioning from no, from just using an input to suggest an output to being more of a decision maker. And what this means is that there is significant an ethical dimension to it as well, because as you can imagine, for each decision made, there would be moral dilemmas that need to be seen. And then the other would be that, okay, a system is fully autonomous, but then what does it mean? What does it mean for actions and consequences that happen after the decisions that are made? So that would be a very interesting piece, and I covered that in the next slide. So without further ado, let me come to the next slide on the technical challenges. So I think the number one, I already gave a teaser on the previous slide, that AI would have its own bias basis the sort of training it has received, and how would it handle unpredictable scenarios? How would it handle real world data limitations? Another thing is, because the topic is on supply chain and logistics, is that how do we prevent bias in AI? The user training the AI would have their own bias. and the data being trained on would also have a bias. So that is one area which would need to be sorted. The other is, like I said, the regulatory and ethical concern. Who would be held accountable in case AI makes a mistake? Another one would be cybersecurity threats. What if a car gets hacked, causes an accident, and injures someone? Who would be held liable? Would the insurance cover that? So I think those are the sort of topics that need to be answered. And finally, around public trust and adoption, I think AI is often portrayed to be a replacement of human workers. Generative I think all of us have been using it and has only worsened the fear that people have of losing their job through. So how would general public react to widespread use of autonomous systems? And then who looks after people who lose their job via AI? So those are the sort of questions that need to be answered if we are to see mass adoption of AI-driven autonomous systems. Now, coming towards the safety and risk mitigation. So I think I've so far portrayed a very dark and gloomy picture of AI, but there is also a bright side, a silver lining. There are significant efforts underway to address challenges highlighted earlier. One of them is explainable AI, where AI, for example, if used to select suppliers, so then the question, why was supplier A chosen over supplier B? Currently, the most prominent generative AI model that actively provides reasons for its thinking way is Google's Bard, in which you can see a complete list of why a decision was made and what were the reasons behind it. I think a similar approach for AI-driven autonomous systems would lead to wider acceptance as well. And then within the EU, there are efforts underway. EU has come up with an AI Act. The goal of this act is to promote innovation while ensuring high levels of health, safety, and fundamental rights of protection. It's part of a wider package of measures to support the development of trustworthy AI. And then again, building in redundancies, which is basically having fail-safe methods in autonomously driven systems, would also improve and help with the public perception when it comes to safety. Another factor is that even if a system is fully autonomous, having a human in the loop would ensure oversight in critical AI decisions. So that is also something which can be put as a mitigation factor. And then finally, sorry, my bad. So finally, testing and validation. It's all around knowing that although trials and simulations are great, but systems should be put to test in the real world to validate them for real-time applications. So that would be another area which could help AI gain more acceptance and credibility. Now, lastly, coming towards future trends in AI-driven autonomy, I think I already said I see autonomous vehicles seeing a significant application in last mile. So I got the chance to work for Arrival, which is a UK-based company, which is producing electric vehicles and autonomous vehicles as well, or at least is trying to do so. They're still in the prototype phase. But I did a consulting project for them, and they were looking for use cases for their autonomous vehicles. So as a sneak peek, I have included on the next slide a picture of what sort of research that I did for them and what were the findings. So I would run you through in the next slide. Uh, Swarm intelligence is another one. So I see in the next 5 to 7 years, a fleet of drones operating in the air, delivering orders for last mile. So I think that would be another advancement that we would see in the coming years. And then I think in general, AI would transition from narrow AI to a broader intelligence AI, which simply means that rather than having very niche and unique use cases, you would see AI's mass adoption in applications which require more broader intelligence than say more concentrated users. And then finally, using all of the arguments I made above, AI-driven logistics would reduce delays by 40% because everything would be connected, delivery times would be super low. So I think all of that would contribute to reducing delays. And then also, I believe that there would be a significant reduction in transportation costs because of all the advancements I mentioned so far. And then, like I promised on the last slide, uh, just a sneak peek into the sort of work I did for the company I was selling about. They were interested to find out what would be the best use case for autonomous vehicles. So I looked at three different areas which could be of interest. One being parcel delivery. So parcel delivery means vendors like Amazon, Hermes, or Royal Mail. So that was one area I looked at. The other one was food delivery, again, something which is very popular these days. Everyone is getting used to Q-commerce, which is quick commerce deliveries within 1 hour or 30 minutes. And then groceries was another sector. So I looked at parcel deliveries per day, what the size of the market was, who were the major players. So I think this helped me funnel down or drill down on which application would be the most useful for AVs to be adopted in. So like I said, this was just a sneak peek into uh, what the sort of work I did for the company. Now coming to the second last slide on my presentation. I think already in the presentation itself, I discussed in depth about Waymo and how they are working on both fully autonomous taxi service already in the West Coast. I think, and then Boston Dynamics was acquired by Hyundai Motors in 2020. But I think its pioneering work in the field of robotics deserves a mention. So if any one of you hasn't done it already, do have a look and on YouTube, where you would find a lot of videos on Boston Dynamics and the robots they have been making for decades now, and super impressive stuff. So I think I did not want to conclude the conversation without mentioning them and talk about AI-driven autonomy. So definitely a mention there. And then finally, Amazon's warehouse automation, basically robotics optimizing logistics. So I think again have spoken extensively in the presentation around how Amazon is using AI to basically optimize and ensure competitive advantage in the work it is doing. And then finally coming to my conclusion slide. So I think so far, I hope I have made the argument strongly that AI is indeed revolutionizing supply chain and logistics. I think the final thought from my side would be that we need responsible AI development and also regulation to make sure that it is a long-term success and a positive contributor towards last mile and supply chains. That is essentially it. And then, yeah, and then I open the floor for questions. Let me see if I can.
Okay, thank you, Mamoon. It was perfectly clean. I think, yeah, we have about 10 minutes for question,
Sure.
and let's wait about 2 minutes. I think it will text in.
Okay.
Oh, yeah, I see first question. Thank you a lot for the material. I would like to learn about your experience. What were the most difficult and simplest cases in your work?
Okay. Thank you, Vera, for the question. Yeah. So I think it is a very good question and a very complicated question as well. I would say there is like I mentioned in the presentation as well, there is this general feeling that especially AI is great if you get it to make recommendations. I think because then the human element is not, say, triggered or threatened by the application. What I mean is, if for a AI, if I want to model or if I want to make a demand forecast, if an AI can give me a recommendation, I think I would be more likely to accept it as a recommendation and then base my decision on that recommendation, either deciding to use it or either deciding to reject it. But I think especially in the autonomous systems I mentioned, I do see that the adoption there, and for example, in my experience when I was working on autonomous vehicles, anytime an AV, an autonomous vehicle, made a mistake, I think there were more questions raised. And I think the perfect example would be if someone follows the US news, you would see that anytime a Tesla or a Waymo crashes, as in the autonomous vehicle, the coverage that it gets is huge, and you start thinking, okay, autonomous vehicles are not safe. Whereas you know for a fact that even simple cars, as in non-autonomous cars, there are 1.2 million accidents per year, which, and if you compare that to autonomous vehicles, it is significantly less. I understand that the driving time of them is also significantly lower, but even if you compare apples to apples, as in on a million opportunities basis, DPMO, you would still see that AVs have significantly performed better over, I mean, if you were to compare them with normal vehicles in terms of accidents. But still, you see this panic button that is pressed anytime a Tesla or a Waymo crashes in the US. So I think that part is the complicated bit in my understanding, that when autonomous systems would make decisions, what would be the chain of custody, who would be held responsible. So I think those are the sort of questions which would see the toughest, I mean, would need the toughest regulation and also very clear regulation. So that would be my answer to that. Where I hope I answered your question. Whereas in other cases where the application is more straightforward, like the sustainability project I told you about, where I'm using AI to pull features of a shipment and then using it to basically help me going a package free. I think those are the simpler applications, I would say.
Okay, next question is you mentioned the drones that are
Mm.
used in shipping. I want to know in more detail, in your opinion, why drones are not so widespread in this area now.
So, Damir, it's a great question. I think I again, it is interesting because 3 years ago, I think it was 2022, I was asked by a drone company to basically consult for them, and this was exactly what we started. And then to answer your point, I mean, the headline of the answer would be regulation. And what I mean is, in the drone company I worked for, so they basically had a drone and they were looking for use cases for drone. So e-commerce, I mean, at the time their use case was different, but one area where we ran into significant problems was around regulation. Uh, in the UK at least, there were so many regulations on how high a drone can fly, how long can it remain in the air. And as you can imagine, there were safety considerations that need to be factored in. So that would be one. And then also, if I think from more of a e-commerce standpoint, for example, if Amazon wants to deliver under 30 minutes, I think that is also complicated. A, because of, like I said, the regulation piece. The second is also around the infrastructure. And what I mean by infrastructure is, you have a drone flying and then you need to land it at somewhere. Yes, Google Images and Google Maps would help, but then again, it's a constrained environment, and especially the handshake. So handshake means where the customer comes, takes its package from the drone and walks away. I think that handshake is also still a complicated piece which needs significant upskilling of people. And I think those are the two or three areas. So customer adoption, legislation, I think those are the two key factors which have meant that you do not see yet autonomous drones delivering Amazon parcels. But like I said, I think there significant work is underway to handle both. I think, like I said, in the EU at least, again, lots of work is being done on how do you grant licenses to drones so that they can deliver for companies. But as you can imagine, I think the human race, we have always struggled with controlling technologies. And I know it would take the conversation in another way, but think of cars again, for example. We have had cars for how long, right? 100 years, but we still see lots of accidents on the road. So even after trying to control traffic, setting up roads, setting up legislations, setting up the infrastructure, we still see tremendous accidents. So I think that the containment of technology in terms of drones is also and I think similar applies to autonomous vehicles. I think we have not yet cracked the containment question. How do we ensure we set up a safe ecosystem for the technology? And I think that is where we are lacking right now, and that is the reason why you do not see already drones in the air. But like I said, I am super optimistic. I think there would be drone deliveries in the not so distant future. Even I think Amazon Prime Air is already doing it in parts of the US, and I think we would see greater adoption in other parts as well.
Okay, I see two questions left. First of this is thank for the lecture. Everything was clear and clearly presented. I have a small question. How do you think small and medium-sized enterprises can most productively use AI to improve supply chains?
Perfect. I think technology. It is Timur, right? Timur. Timur. So I think technology. I would say in general has greatly democratized power. And what I mean by that is, imagine say 20, 30 years ago, it was very difficult for, say, SMEs, small and medium enterprises, to have the sort of data available or to have the sort of computing power available to do complex stuff, right? But now I think I mean, I have my mobile, you have your mobile, you can have access to the best platforms. You can go on YouTube, you can have access to like knowledge super easy. And I think even with your question, I think teach companies like, I mean, software like ChatGPT have made it super possible for anyone to get access to information which in the past would have been difficult to access for, say, small and medium enterprises. So I do think in the future, I think although agreed, companies like Amazon have significant advantage on areas such as last mile delivery, for example, or warehousing, where you need significant capital and also significant resources to operate in. But I think I do see that there has been, I think it is called the breaking down of the value chain of companies, right? Because in the past, the ideal scenario would have been for example, for an automotive company to do all the R&D themselves, to make all the parts themselves, then assemble the car and send it out. But you do see now that because software is so prevalent now in everything, there has been a breaking down of the traditional value chain. Now you can have the software is being done by one company, the a small part is being made by another company. So lots of distinctive competencies have emerged where the traditional value chain has been broken. So I think in terms of SMEs, I think no, I don't think there has been a better time for SMEs to operate, because the traditional value chain is broken. You can have a very niche product offering, and if you are the best at it, you can enter into that market. So I do feel on the question that how can I mean, I think because of that answer itself, because of the value chain being broken, it is the perfect time for SMEs to develop an idea. It does not need to be from the top to bottom, but find a niche where their product will do better and use it to enter that market. So I think that would be my answer. Timur, I hope I answered your question.
Okay, and it's left one question, but
Mm.
before Vera text cool, thanks for your answer, and Damir text okay, it was clear, thank you. And the last question is thanks for the lecture. Question: what real world examples, sorry, demonstrate AI driving cost reduction and profit growth in supply chains?
I think everywhere. The examples I gave, demand forecasting, massive area. You use AI to basically predict stockouts. I mean, I think it's very famous in Amazon, about Amazon, that they know in a certain locality how many households will require what item in the next 1 month. This is the level of detail you can have using AI and using predictive analytics. So I think demand forecasting, knowing what will you need in 1 month, is something which e-commerce companies are getting really, really good at. And like I discussed in the presentation, last in stock is just a metric which shows that how good these e-commerce companies are getting. Obviously, they're using our data in a certain way, which may or may not be acceptable to some people. But I think that is a massive, massive area. The other one is route optimization. I think the sort of route optimization happening in last mile logistics is awesome. And I think that is another great example of where AI driven cost reduction and profit growth is happening. So I think those would be the two off the top of my head, massive examples of AI driven cost reduction. And then I think, like I said as well, even within under the roof operations, AI is enabling so many different applications, and all of them, I think, are examples of where AI-driven cost reduction and profit growth in supply chains.
Okay, I think that's all. The last message it's from Timur. Great, thanks you, and I think it's over. Thank you, Maimoon.
Perfect.
Now, sorry again for your lecture. It was clear and cool presented.
Perfect. Thanks a lot. I would like to thank everyone who joined the talk here on a Sunday evening. I'm sure it's not easy, but great to talk to you. And then yeah, happy for you to connect on LinkedIn or anything if you ever need to talk.
Okay.
Thank you.
Thank you.
Bye everyone. Bye.
Okay. Bye.